In one of the world's most polluted countries rises a 71-story antidote. A tower designed to conserve energy, harness the wind and sun, and generate as much power as it uses. The builders call the Pearl River Tower the world's greenest skyscraper. If they succeed, they'll write the blueprint for the buildings of tomorrow. If they fail, they'll leave a towering mistake. Today, as oil reserves dry up, engineers and scientists are inventing other ways to power our cities. Solar, geothermal energy, fusion, wind, and buildings that redefine the skyscraper. A new era of ecological engineering has arrived. % of the world's energy goes into buildings for lighting, cooking, heating, and air conditioning. Functions that not only gobble energy, but release greenhouse gases. Architects are billing the Pearl River Tower as a giant antidote. At 71 stories, it will become the second tallest building in the city of Guangzhou, in the southeast of China. The tower is just one of many buildings under construction. A city hungry for development, Guangzhou typifies modern China, a place pressed for time. The Pearl River Tower is part of the future Central Business District. When complete, it will take pride of place in this booming metropolis. For now, this whole area is a huge building site. All the work must be finished by 2010, when Guangzhou will host the Asian Games. China intends the Pearl River Tower as a sign that the world's most polluting nation is starting to clean up its act. To build this ecological high-rise, 4 players have a key role. Roger Fresnel is the architect in charge. He specializes in clean energy for buildings. If this ambitious project meets its goals, it will be Roger's greatest success. It's also his greatest risk.
It's really a very critical time in the history of the construction industry. The problems that the world sees right now with the global warming and shortages of energy are forcing us to rethink how we design buildings and how we build buildings.
Pan Xuanzhu and Xu Chaoshang work for the Shanghai Construction Company. They're in charge of every stage of the work and hundreds of Chinese workers. Whatever happens, they must stick to the tight construction schedule.
I've been doing this kind of work for 20 years. This is the biggest site I've worked on in my entire career.
It's also the boldest. The technology is new and untested.
It's the first time that I've taken part in the construction of an ecological high-rise. There are a lot of difficulties and technical problems during the construction. For me, it's a huge challenge to manage the whole of the site.
And finally, standing by in Finland, Risto Jutsunimi is far from the building site, but close to the project. He's the brains behind the huge wind turbines that are key to powering the Pearl River Tower.
It is my dream to get the earth going without polluting it, only make it really green.
Together, This international team of eco-engineers faces the challenge of a lifetime. The deadline is fixed. Whatever problems arise, they have 2.5 years to transform this hole into the world's most ecological skyscraper. Roger's firm, Skidmore, Owings & Merrill, knows all about building skyscrapers. In the past 70 years, they've completed more than 10,000 projects in more than 50 countries, but nothing like this. A building that taps the wind and the sun to produce as much energy as it uses. A building that curbs pollution instead of creating it. Buildings may seem inoffensive, but Roger knows they're a huge source of greenhouse gases.
When we think about the problems of global warming and carbon emissions, most people think about cars and buses and transportation and factories. But the reality of it is that there's more carbon emissions that come from office buildings and residential buildings than from those other sectors. Well, in this decade, China will become the largest user of fossil fuels on the planet. But for the first time, China is realizing that their own natural resources are limited, and they need to find ways to reduce the amount of energy that they consume. So how people use buildings, how people survive within buildings is going to be very important to our future.
In the last 10 years, Guangzhou has grown from 8 million people to 11 million. It's one of the most polluted cities in China, a country that has 101 cities with more than 1 million inhabitants. It's more than 7,000 miles from Chicago to Guangzhou. An even longer journey lies ahead for Roger Frechette.
Ni hao. Hello. How are you? Nice to meet you. It's great to see you.
Roger is making his first visit to the construction site, where work will hum for the next 2.5 years. On this spot, his dream will come to life. A revolutionary skyscraper, integrated into its environment to tap clean energy.
Site of the Pearl River Tower. Off to the right here is the hole. Right now, the project is still well below grade. The hole is about 28 meters deep. When the project is complete, it'll rise roughly 309 meters into the air. To put that into perspective, this building off to my right is roughly 100 meters tall. So our project will be roughly 3 times that height.
Throughout construction, Roger will have to negotiate a slew of challenges. Unforeseen setbacks. New techniques. Cultural differences. And diplomatic solutions. Above all, looms an unyielding deadline. The tower also has to guard against unseen forces. China is one of the world's most earthquake-prone countries. Guangzhou itself lies near a major fault zone. For the tower, protection starts at the bottom. The tower is designed to withstand a quake measuring 6 on the Richter scale, almost as bad as the 1994 quake that rocked Northridge, California. Erecting the vital foundations is just one of 1,000 burdens for Pan Xuanzhu, the site's foreman. He supervises an army of welders, steelworkers, and crane operators. Pan Xuanzhu is the tower's linchpin, the link between the engineers in their offices and the teams on site.
My work goes like this. First of all, I have to establish plans for how to execute the job. Then I pass these plans on to the workers. Every day at midday, I go down to the site to look over the work myself and see if everything's been done the way it's supposed to. We have 500 workers on the construction site right now. Their tasks are well defined. A professional team installs the cranes, and then there's a second team working on constructing the beams and putting the steel framework in place.
Pan Xuanzhu makes sure the engineers' plans are followed to the letter. In this 3D jigsaw puzzle, one slight deviation could cost millions to fix. This metal forest will safeguard the foundations against quakes. The ground may shake, but the tower won't budge. It's a labor-intensive part of the building process. Because the tower site is so complex, Roger Frechette visits regularly to brief the managers. He also checks the coordination between the specialty workers and makes sure work is advancing as planned. But there's a hiccup, and Roger needs to meet with the local team to fix it. Some of the Chinese engineers are questioning the revolutionary ventilation system. They're wary of the new technology. It's a classic situation for Roger. He wages a constant battle to change habits in the world of construction, and language complicates every problem.
I think this is really important. I think that this is something that we really need to focus on, and I think time is short. And one of the real benefits of having a double wall is that we have the ability to isolate that hot air, that energy, and to pull it out of the building.
While Roger and his team aspire to revolutionize power consumption, the local engineers prefer their tried and tested methods.
But I wanted to make you aware of our concern and why we are concerned about pulling this hot air through the chilled beam.
To win them over, Roger must be diplomatic, but firm.
A certain quantity of air that has to be rejected.
He can't yield if he wants to realize his dream. A building that generates all the energy it needs. No single solution exists. He requires a cocktail of skillful technology and ingenious design. First, the very position of the tower is key to tapping two large sources of energy: the sun and the wind. The tower walls facing the sun are covered in photovoltaic cells, and the tower's aerodynamic shape attracts and accelerates the wind toward its 4 huge turbines. Unlike most buildings, the tower will let in a flood of light to conserve electricity. At the same time, a protective layer on the facade will capture excess heat from the sun to keep the interior cool, without relying on energy-guzzling air conditioning. It's this combination of technologies that makes the Pearl River Tower the first of its kind. Roger returns to his office in Chicago and hopes that the local team has fully understood what he has told them. The engineers' qualms have caused delays. The deadline is a mere 18 months away. Although the core of the tower has passed ground level, the basement floors still aren't finished. The site is as busy as an anthill. Workers measure thousands of planks, which will form a temporary mold for each of the concrete floors. Steelworkers will then construct the metal structure to support the reinforced concrete. A whole floor takes shape, and the process will be repeated 71 times until the tower is complete. With an unyielding deadline, the management has to find a way to make up for lost time. Simple. Work into the night while the rest of the city unwinds. Xu Chaosheng is brought in to get the work back on track. The weight of the skyscraper now rests on his shoulders. It's also a chance to shine by pioneering time-saving techniques. He puts his ideas to the test at once.
Today, we're mostly working on pouring the concrete in the East Zone. It takes about 30 workers. By this evening, we will have poured 1,000 cubic meters of concrete. In the other zones, we're building the metal structure so we can be ready for the concrete there.
Xu decides to pour concrete for one vast area rather than pouring it in smaller sections. If it works, he'll save precious time. Xu's move is bold. It allows no room for error. The vast operation begins. More than 1,000 cubic meters of concrete are about to be poured, the equivalent of 50 cement mixer trucks. Weeks of sweat will be tested in just minutes. Everyone's gearing up. Tension mounts between the bosses and the workers. It takes a huge amount of coordination to organize the arrival of the mixers, pinpoint where to pour the concrete, and spread it properly. The construction supervisors are under pressure. The process requires teams of laborers, intense concentration, brute strength, close supervision, and long hours without a break. As each load is pumped in, the floor begins to take shape. If the structure is poorly made, the concrete will pour into the wrong place. Then all work must stop while they make urgent repairs, with a slew of repercussions. Workers placed on standby, cement mixers sent back, and a chain reaction of delays across the site. If parts of the steel structure are missing, a weak point will be created that won't be detected once it's covered in concrete. By the end of the day, success. At the other side of the site, teams of steelworkers continue non-stop. In less than a week, it will be their turn to have concrete poured. In all, it will take more than 3,000 cement mixer loads to build the tower's foundations. The site managers check all the team's work and study the engineers' plans in detail before giving the orders for the day. Tons of steel rods are received and positioned according to the blueprints. At every step, surveyors watch for the slightest deviation from the plans. The tower is rising above ground, but work continues in the foundations down in the bowels of the building. Not all challenges on the site take the form of concrete and steel. Some are flesh and blood. Xu has had to recruit more workers to stay on schedule. The workforce hails from all over China. Most come from Shanghai, a city over 700 miles away. Others left homes even farther away. Their lives now revolve around the building site. Co-workers have become family. The site has become home. In a vast country like this, there's no common language. China speaks more than 100 dialects. Dozens are spoken here alone. Mandarin, one of China's 7 major languages, is used to communicate key information. No time for misunderstandings here. Clarity counts, and for the clearest vision of the site itself, you need another perspective. A view from the tallest building in Guangzhou, the TV tower. From this height, Roger can show how location will shape the ability to generate power.
It's very important in the design of the Pearl River Tower that we take into consideration the context, the physical context and the environmental context. The Pearl River Tower is going to be built along a central axis for the new central business district in the Newtown area of Guangzhou. The building will be located on the northwest corner, and in this location, the building will have uninterrupted access to sunshine through most of the day. As the sun rotates through the sky, we have this great park that will sit in front of the building that will not block the sunshine that will come in contact with it.
By carefully angling the skyscraper, the architects will fully exploit solar energy. The sun's rays are strongest on the south and east. Photovoltaic cells will be integrated into the building's external shading system to provide electricity, but also to protect workers from excess solar radiation.
But the other thing that happens is the prevailing winds in Guangzhou for most of the year are coming from the south. And as these winds pass through this new central business district, there will be no other buildings blocking this wind before they come in contact with the Pearl River Tower. So the winds will hit the turbines, and they will be the first thing that the wind sees. But between absorption of wind and absorption of sunlight, these energy streams will be turned into power, and this power will be what helps to drive the building.
But at the site, the building is far from finished. Xu is installing a new crane to speed things up.
Yesterday, we finished installing this large blue crane, which is 54 meters tall. It will be used for lifting big girders like this one. It can lift a maximum of 64 tons. That's enough for all our needs. It's special because it can rise up as the tower rises. In other words, its height of 54 meters doesn't change, but it can rise with the tower. Now we're going to test it by having it lift this 20-ton girder. This test is supervised by a team from the government in order to validate it.
If the test fails, the time can't be replaced. But Xu might be.
After we've lifted the girder, we'll do a multi-directional test of the crane. After that test, we can be completely confident about this crane. We'll know it can finish all the work we need it to do.
Everyone's on standby till the results come in. The crane passes with flying colors. Now it can start hefting all their loads and make construction fly. Within weeks, the core of the tower reaches 40 meters, 120 feet. To work at these heights takes the construction equivalent of trapeze artists. They're called steeplejacks. They'll erect the steel frame that surrounds the core and supports the extremities of the higher floors. Their best friend, the safety rope. Although the steeplejacks are all qualified climbers, the work is risky. These guys require a combination of daring and caution. A tool dropped from these heights could kill. To maintain the tower's balance, steel girders weighing more than 10 tons must be precisely positioned. Since the crane operator can't see so far, the steeplejacks talk each girder into place. They'll bolt, weld, and if necessary, adjust the girders. No room for vertigo here. Steeplejacks, steelworkers, concrete. Work has been going full steam for a year now. Next comes a huge step.
This is a critical point in the work on the core. We're about to install our self-climbing scaffolding system. Using this system, we'll be able to take away the scaffolding. The support sockets are already installed here, where the self-climbing system will be attached, and it's almost all assembled at the bottom.
This system is the only one of its kind in China. Along with the crane, Xu hopes it will help keep construction on schedule.
After all that, we'll be able to do all our work on the core using this automatic system, which is controlled by computers. So from that point, we'll be much more efficient. We'll go from taking 12 days for each floor to 4 or 5 days. And at that speed, we'll be able to build the core to a height of 300 meters in 8 months as planned.
In a nation of 1 billion people, Sheng Xingwan is unique. He's a specialist in this kind of system.
So these are the support frames for up there. We'll fix them in place by bolting them. We can also suspend a platform inside the core, where the workers can work and advance on the building of the tower. What we're making is a kind of interior scaffold that can change shape depending on the structure of the building. When we pour the concrete for this wall, the shoring will rise automatically in accordance with the building, using the hydraulic jack system. For example, if the floor is 3.5 meters high, the platform can rise up 3.5 meters to start work on the next floor to be constructed. So the workers can then start working on the steel frame and place the shoring before pouring the concrete. and so on and so forth. We'll climb like that up to 300 meters. That's the process.
It's a big day for Sheng. He has to coordinate the installation of all the platforms inside the central core and the blue structures on the outside, so crews can work safely without scaffolding. If all goes well, the backbone of the Pearl River Tower will start to take shape at a meter a day. This Leviathan can manipulate these mammoth components with the precision of a surgeon's scalpel. Sheng guides each section into place by keeping in constant contact with the crane operator. At the same time, teams are assembling the platforms so work can continue as soon as the self-climbing scaffolding is in place. With his innovative ideas, Xu has recouped lost time. Construction moves at full speed. Now the tower can be seen from a distance, standing 100 meters tall, almost a third of its eventual height. Girder by girder, the skeleton takes shape. As the framework rises, the floors follow close behind. And Xu has more tricks up his sleeve.
For the floors, we use a very advanced technique. It's already used in Europe, and we've adapted it and improved it for our local needs. The biggest advantage of this galvanized steel floor is its system with no supports. That means we don't need scaffolding to support it underneath when we pour the concrete. We build right after laying the flooring, so it serves as a supporting form and allows us to eliminate shoring up. Its lateral mooring means there's a close relationship between the steel and the concrete, and the frame can support the weight of the concrete and the people working on it. So the entire operation is efficient, quick, and allows us to work in complete safety. For a floor of this type, we need a dozen or so workers who work for 3 days to install it. After that, we'll need a day for the metal frame, a day for the concrete, and with all the work together, we'll need almost 4 days extra. After that, the floor is finished.
The progress impresses a visitor, architect Roger Frechette. Barely a year has passed since he first came to the site. It's gone from a hole in the ground to a vision in the sky, the green workspace of tomorrow.
This is what will be a typical office floor within the building. And if you can imagine, about 1 year from today, what you'll see is a couple things. One, you'll see a floor system, and the breathing air for the building will come up from underneath your feet. It'll come from the floor, and it'll rise up with natural buoyancy of air through the breathing zone, and that's how people will get their fresh air for the building. What you'll see at the ceiling is there'll be a number of concave metal panels, and those panels will be cooled down, and at their cooler temperature, there'll be a radiation exchange that happens between the panels and the people within the space, and this is what's going to make them feel comfortable. When we go over to the perimeter of the building, what you'll see is there'll be what is known as a internally ventilated double wall facade.
As the sun comes in contact with the skin, it heats up hot air within the layers of glass of this exterior wall. That hot air is then drawn up through the building, and we can use that hot air for other purposes.
So air from the space will travel low into the exterior wall and will rise up between the layers of glass in the space. And it is that air movement in the glass that causes a cooling of the glass and will help to maintain thermal comfort in the space. Now, hot air that is collected in that glass will be brought back to a technical floor, and we'll be able to reuse that energy elsewhere in the building.
Roger heads to the rooftop to review the work with Xu Chaosheng.
For the moment, we've built up to the 22nd floor. That's where the wind turbine will be placed. A few days before, we were here, and the construction of each floor took about 12 days. However, we're getting faster and faster. Having built 10 floors, we can now build a floor in 3 days. So we're very confident about finishing the work at the end of the year. This building will be one of the 4 highest buildings, with the TV tower behind and the Chongqing Square over there.
Where we are right now, the first mechanical level starts about 1 floor above us. And it's at that mechanical level that we'll have the wind turbines. You know, it's quite nice. When we were down on the ground, you couldn't feel any wind at all. But now you're up here, there's a nice breeze. You know, so I'm very excited. I think when these turbines are in place, they'll really do a good job. They'll be able to generate a lot of power.
But how do you insert a wind turbine, a notorious source of vibration and noise, inside an office building? Roger and his team had to go to Finland to find the solution. In this Scandinavian country, where the sun appears for only half the year, inhabitants have tapped an alternative source of clean energy. As well as classic turbines, you find designs adapted to city life. No noise, not even vibrations. A jewel from the north, brought to the Pearl River Tower. The man who pioneered vertical turbines in Finland is Risto Jutsuniemi. Risto's company, Windside, has the longest track record for making urban turbines. So the designers of the Pearl River Tower chose him to help build a new concept into the world of architecture and give their skyscraper a green advantage.
This building is like sail, so it means that it is very high wind pressure. Other buildings you build so that they are taking care of the wind otherwise to try to get the wind away from the house. Here you are collecting it. We have here south, and here other side we have the north, and the prevailing wind, the main wind, comes from the south.
On the turbine floors where air is funneled into tunnels, the Pearl River Tower taps a phenomenon of fluid dynamics called the Venturi effect. When the space narrows, the air particles accelerate. So the faster wind speed produced means more energy will be produced by the turbines.
The power production is also something what we have records in this kind of wind turbines. So we can say that it can be 1 megawatt per 1 square meter in this Pearl River Tower. So when we get this square meter power to our knowledge, we can do whatever. It's very inspirated project, and very, very challenging and good for us. Here it is what I want to show you. This is a special windmill, which is approximately 1 meter wide and 4 meter high. But this is the only windmill what you can put in urban circumstances. It is totally soundless. This is very special model, and you can put it wherever you want, even middle in town, as you can see. If you have propeller, you cannot put propeller roof of the house because there's a lot of noise. There is 0 decibel. We are so near and you cannot hear anything. This is our specialty. You can touch your bare hands to our turbine, and this is not dangerous at all. This is the only turbine, what I know, that you can touch even when it is moving in full speed, and you cannot make any dangerous things. So it doesn't kill birds or anybody else. And you see there is rather good speed already, and there is maybe only 3 meters per second wind. And it doesn't go faster than this. This is why it's so safe. It is always going this slowly rotation. And it's only, the torque only comes bigger and bigger. And this is just perfect for like Berwick River Tower.
The University of Vaasa is known for its research into electronics. Risto has made this his test lab. With his colleagues, he's working on a system to monitor his turbines remotely. He can check wind speed, wind direction, and power output, and use a webcam to spot problems. Risto needs all this data to keep improving the system he created and to replicate this model at the Pearl River Tower.
This is what we try to do in China. We have 4 turbines and we have 4 monitors, and we can look from here what happens and what is the production in China. I think this can to be very beautiful cooperation with the university in the future.
At the building site, the floor that houses the turbines is about to be constructed. Here, the facade narrows down to the floor where the turbines will be installed. At this height, architects have calculated the wind should accelerate by up to 250% before reaching the tunnel where the turbines are housed. The curve is created using custom-shaped girders, perfect for the turbines, but a nightmare for the construction teams. They must be positioned with absolute precision. And fixed securely once they're in place, under Shu's eagle eye. The last big girder for the turbine floor arrives. As with the others, just getting it off the ground is a headache.
This metal girder weighs about 21 tons. Its special, non-rectilinear shape gives us real problems for lifting. We really need to pay attention, because it's very difficult to find its balancing point and to work out its center of gravity in order to lift it properly.
It's a dicey operation. In cutting-edge construction like this, each step has its complications. Almost the entire 19th floor has been built. All the girders are bolted and welded together. Total weight, 400 tons, equal to one jumbo jet full of passengers. Everything must be checked once and for all to detect any problems that could upset the schedule for the other floors.
现在已经到20层了嘛，对吧？现在是8节柱，对吧？8节柱。
Now we are lifting the girders for the construction of the 19th and 20th floors. For everyone,
Reaching the turbine floor is symbolic, a milestone not just for the tower, but the nation. Engineers, foremen, workers. Everyone is working full out so the Pearl River Tower is completed before the Asian Games in Guangzhou. Whether they finish on time, they hope to meet a far bigger goal, planting China's first seed of clean energy.
This tower is the first real ecological building in China. It's the first time that a skyscraper has brought together 11 ecological technologies that allow us to reduce our energy consumption. So the ecological skyscraper is exactly what the Chinese government is aiming for. In fact, at the moment, the current government wants to move more and more towards new technology and clean energy.
I'm very proud of this ecological building project. Nowadays, everyone in the world is worried about protecting the environment. And I think the ideas behind this project and this building are excellent. I also hope this kind of ecological building will be used as a model for other buildings.
The Pearl River Tower, I think, represents a big step forward in the science of sustainable buildings. And we're hoping that it's something that others will study and will learn from and then will carry forward.
Even unfinished, the Pearl River Tower marks a new era in architecture, when concrete, steel, and glass will all share the same color, green.